Now, we're going to be analyzing a problem 4.33 of SVA, which states, so let me just write the combustion reactions right here below. Now let us consider what the products are. So we are assuming complete combustion, and to make things simpler, we're just going to assume a feed of 1 kilomole feed. This is our basis. So if this is 1 kilomole, this will become... Now we have to convert these into CO2. 0.75. See, it's a 1-to-1 ratio, so I'm just going to leave as 0.75. Next, I'm going to get 0.25 and I'll multiply it by 2. And we will get 5/4 or 1.25. Next, we're going to calculate for the H2O. So that's 2 times 0.75 plus 3 times 0.25. You're going to get 2.25. Now, the question is, we don't have values for O2 and N2 yet. So all we know is that it is 80% excess. So we're just going to use our extent equation. But first, we need to determine the theoretical O2. So that is 2 multiplied by 0.75 plus 7/2 of 0.25. You get 2.375. Everything clear so far? Now, we have to get our percent excess. So we'll just use our excess equation, which is x minus 2.375 over 2.375 is equal to 80%. This is in our stream. So rather, this is 4.275 kilomole. I'm just going to write it as km. Don't confuse it with meters, please. Next, we're gonna use 4.275 multiplied by 79 divided by 21 to get the nitrogen. So I'm just going to leave this in fraction form since it's better. Yes. Now, we are aware that all of the N2 from this stream, since it didn't react, will go to this stream. So then I'm just going to minus this amount to the theoretical amount. So 4.275 minus 0.375, you'll get 1.9. So I'm just going to put here. Now, the first thing we should do if we encounter problems like this is we draw a schematic diagram. Now, we know that these two are in 30 degrees Celsius. And we also know that after combustion occurs, there will be an exit stream for Q, which is 8 times 10 to the 5th kilojoules. Now we are looking for the temperature of this stream. Now, first of all, we have to determine the schematic diagram of how we're going to do things. So first, the best thing to do is, since these reactions will occur in 298.15 Kelvin or 25 degrees Celsius, we have to change this temperature to 25 degrees Celsius. We'll change all reactants. That is from 30 degrees Celsius. We're going to transfer them to 25 degrees Celsius. From here, you will get your first enthalpy. Okay, I'll label that as first enthalpy 1. Next, we're going to make them react such that this stream will go out. So this is your delta H2, or this is your delta H of reaction. Next, we are going to heat it up to a certain temperature. This is at 25 degrees Celsius. This is at temperature is unknown. And this is our delta H3. Okay, I hope you're all clear with the schematic diagram. I'm just going to draw a little barrier here so that you will not get confused. Okay, this is our schematic diagram. So more or less, we're going to be doing 3 enthalpic parts. Now, we'll start with H1. So at delta H1 is just sensible heat, so we're just going to use the integration equation. So I prefer to use the ICPH, if that is okay with you, as I love to do integration. separate each component and just add everything up. So what I'm going to do is I'm going to get the delta H of CH4, of C2H6, N2, and O2 separately. So given here, so I'm just going to plug in a general integration equation. You may actually do this. So I'm going to label as E and F. Then our integration in our SVA is A plus bx over 10 raised to 3 plus c x squared divided by 10 raised to 6. 10 raised to 6 plus d x raised to negative 2 divided by, divided by 10 raised to negative 5. I hope everything is clear. And we're just gonna use calc. You're gonna press calc. We're not gonna use shift solve. Rather, we're gonna use calc. So if we're gonna use calc, we have to input all the variables. So we're gonna do CH4 first. So if I am correct, CH4 is 1.702. Its B is 9.081. It's just gonna skip X. C is negative 2.164. Its E is equal to 27 is equal to the first temperature, which is 30 plus 273.15. Then our final temperature is 25 multiplied by plus 273.15. I hope everything's in order. And you are going to get this value. Now, please take note that this value is just Cp over R. So we still have to multiply it with R. So answer times R. Okay, we have that, and voila. Now this is in joules per mole or kilojoules per kilomole. Now we have to multiply it by the kilomoles of CH4, which is 0.75. So I'm just going to multiply by 0.75, and we should get 132. So this is kilojoule. Now this is only for CH4. Now let's try the same thing for C2H6, for N2, and for O2. Alright, so this is our delta H1. So I labeled that as delta H1. Now let's calculate for delta H2. Now our delta H2 is just the extent of the reaction. So rather, I'll go back to our reaction equations here. What we're just going to do is, we're going to use SVA to get the HF, the H of reaction for this using the heat of formation of the reactants and the products. So CO2 negative 393,509. Then we have to include 2 times H gas, so that's 241,818. Then we're going to minus the delta HF of CH4, which is 74.52. 74,520. Sorry, 520. Now, as you can see, this is plus instead of minus because the delta HF of CH4 is minus, so minus times minus equals to plus. So we're going to get 802,625. So I'm just going to write it here. And we're going to do the same for this. So I'm just going to plug it in directly. Okay. We are here. Now, all you have to do is you just multiply this by the extent, which is, we all know, since CH4 is completely consumed in this reaction, the extent of this reaction is just the number of CH4, which is 0.75. So just multiply 0.75 by this amount, and same goes with here. So just multiply this amount by 0.25. So I'm just going to write it here. So delta H. Okay, we are clear on this. Now, this happened, we're already in the part wherein the reaction is already has already happened. So what we knew is that after the reaction has already happened, the some part of the heat that was released will go out of the chamber. So we know that this is the heat one. Then we're just going to add this to negative 3,168.984989. Okay, then we're going to get a value of this. Then we just add 8 times 10 to the 5th. Okay, then we're going to get this value. So we know that our delta HF, that the delta H3 rather is 162.3, sorry, 300.735 kilojoules. We already know delta H3, but we don't know the temperature yet. So we're going to use delta H2 to get the temperature. So let's write our overall equation. So we're going to write tau as the T over T naught. Everyone, so we already got this equation here. About as I did when I calculated for A, B, C, and D. So what we're going to do now is that I'm going to use 2 calculators such that we are going to be more efficient. So we just plug the equation to this calculator. So we have 74.292278. What I do here is we're going to do iteration. So I've started a new sheet of paper to illustrate on how this works. So what we're going to do is we're going to have an initial guess. Our initial guess here is, as what you said, is 500 Kelvin. So what we're going to do is I'm going to calculate first for tau, 0.6770817. And I'm just going to input it in this equation, which is 1.67700817. Then I'm going to get an answer of this. Then I'm just going to multiply the said answer by R. Then I'm going to get this value. This is in kilojoules. And I'm going to use delta H is equal to Cp delta T, which is your T nu minus your 298.15 Kelvin. So if I'm going to use that, so I'll get our H3 from before, so that is 162,300.735 is allocated to the answer multiplied by a new value for temp, I'll designate it as Y, minus 298.15. Then the new value for temp will be 299,354,2442. So our Tn Kelvin. Then we'll just do the same process over and over again. I want you to do this on your own, and we'll check back on you to see how many iterations you did. Hello guys, so I hope you did the iterations. So these are just some of the iterations that I did. But overall, we are supposed to get a tau value of 1.812211765. Okay, so this is our final answer, and this has been verified by the book, so don't argue with me on this. Just kidding. So yeah, this is our answer. Thank you for everyone who watched this video. If you want to watch more of our videos, please click the subscribe button. Thank you for watching, guys.